NEC Section 310.15 states that conductors of the same circuit, including grounding and equipment grounding conductors, shall be permitted to occupy the same raceway, cable, or enclosure. NEC Section 310.15b states that conductors of different systems, circuits, or classes of voltage shall not occupy the same raceway, cable, or enclosure unless approved for the purpose. In the scenario described, where 12 hot conductors and 1 neutral conductor are present in a conduit from an automatic transfer switch to a subpole during generator operation, this is generally prohibited by the National Electrical Code, NEC. The reason for this prohibition lies in the fact that the 12 hot conductors and the single neutral conductor originate from different circuits. Specifically, the hot conductors are supplying power to various load circuits within the subpanel, while the neutral conductor serves as the return path for those same load circuits. These load circuits are distinct from the generator output circuit, which is the source of power during generator operation. Since the conductors belong to different circuits, they cannot occupy the same conduit according to NEC Section 310.15b. There is an exception to this rule for multi-wire branch circuits. However, a multi-wire branch circuit is a specific type of circuit configuration that involves multiple hot conductors sharing a single neutral conductor, but only when they originate from the same source and serve to supply power to multiple loads in a balanced manner. In the scenario, the 12 hot conductors and the single neutral conductor do not constitute a multi-wire branch circuit because they do not originate from the same source. Instead, they are individual circuits supplying power to separate loads. Therefore, the multi-wire branch circuit exception does not apply, and the general prohibition against mixing circuits in the same conduit remains in effect. To correct this violation of the NEC, the hot and neutral conductors must be separated into different conduits. This can be achieved by running a separate conduit for the generator output circuit and another separate conduit for the load circuits. By physically separating the conductors in this manner, the requirement of NEC Section 310.15b is met, as conductors from different circuits are no longer occupying the same raceway. It is important to note that this correction may involve additional wiring and conduit installation depending on the existing configuration of the system. It is recommended to consult with a qualified electrician to ensure that the separation is performed safely and in accordance with all applicable electrical codes and regulations. Furthermore, when separating the circuits into different conduits, it is crucial to ensure that the neutral conductor for each circuit is properly sized to handle the maximum anticipated current flow. This sizing should be based on the load calculations for each circuit and in accordance with NEC requirements for neutral conductor sizing. Failure to properly size the neutral conductor could result in overheating and potential safety hazards. In addition to separating the circuits into different conduits, it is also important to ensure that all conductors are properly insulated and protected from physical damage. This includes using appropriate conduit fittings and connectors to maintain the integrity of the conduit system and prevent moisture or debris from entering the conduit. Furthermore, any splices or terminations within the conduit should be made using approved methods and materials to ensure reliable electrical connections. When working with electrical systems, it is essential to prioritize safety at all times. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, and following lockout-tagout procedures to de-energize circuits before working on them. It is also important to have a thorough understanding of electrical codes and regulations and to consult with a qualified electrician if there are any doubts or concerns about the proper way to perform an electrical task. By following these safety precautions and adhering to electrical codes, it is possible to ensure that electrical systems are installed and maintained in a safe and reliable manner. In summary, the presence of 12 hot conductors and 1 neutral conductor in the same conduit from an automatic transfer switch to subpanel during generator operation is generally prohibited by the NEC. This prohibition is based on the fact that the conductors belong to different circuits and do not qualify for the multi-wire branch circuit exception. To correct this violation, the hot and neutral conductors must be separated into different conduits with appropriate sizing, insulation, and protection for each circuit. Safety should always be a top priority when working with electrical systems, and it is recommended to consult with a qualified electrician to ensure that all work is performed in accordance with applicable codes and regulations. There are a few other considerations when dealing with generator installations and automatic transfer switches. Firstly, it's important to ensure that the generator is properly sized to handle the load requirements of the subpanel. This involves calculating the total connected load of all the circuits in the subpanel and selecting a generator that can provide sufficient power to meet that demand. Overloading a generator can lead to voltage drops, overheating, and potential damage to the generator or connected equipment. Secondly, the automatic transfer switch should be properly rated for the voltage and current of the generator and the utility power source. This includes selecting a transfer switch with an appropriate ampacity rating and voltage rating to handle the maximum anticipated current flow and voltage levels. Using an undersized transfer switch can lead to overheating, arcing, and potential failure of the transfer switch. Thirdly, the grounding system for the generator and transfer switch should be properly installed and maintained. This includes grounding the generator frame to a suitable grounding electrode and bonding the neutral conductor to ground at the generator. Proper grounding helps to ensure that fault currents can be safely dissipated and reduces the risk of electric shock. Furthermore, it is important to periodically inspect and test the generator and transfer switch to ensure that they are operating properly. This includes checking the generator for proper voltage and frequency output, inspecting the transfer switch for any signs of damage or wear, and testing the transfer switch to verify that it is switching between the generator and utility power sources correctly. Regular maintenance and testing can help to identify and address any potential problems before they lead to equipment failure or safety hazards. When installing a generator and automatic transfer switch, it is also important to consider the location of the equipment. The generator should be located in a well-ventilated area to prevent overheating and the buildup of exhaust fumes. The transfer switch should be located in a convenient and accessible location for maintenance and testing. Additionally, the generator and transfer switch should be protected from the elements such as rain, snow, and sunlight to prevent corrosion and damage to the equipment. In some cases, it may be necessary to install the generator and transfer switch in an enclosure to provide additional protection from the environment. The enclosure should be properly sized to accommodate the equipment and should be equipped with ventilation to prevent overheating. Additionally, the enclosure should be secured to prevent unauthorized access and vandalism. Finally, it is important to comply with all applicable local codes and regulations when installing a generator and automatic transfer switch. This includes obtaining any necessary permits and inspections and following all applicable electrical codes and safety standards. Failure to comply with local codes and regulations can result in fines, delays, and potential safety hazards. Therefore, it is essential to work with a qualified electrician who is familiar with the local codes and regulations to ensure that the installation is performed correctly. The information provided here is intended for general guidance only and should not be considered a substitute for professional electrical advice. It is always recommended to consult with a qualified electrician to ensure that any electrical work is performed safely and in accordance with all applicable codes and regulations. Firstly, determine the load. Secondly, size the generator. Thirdly, install the transfer switch. Fourthly, ground the system. Fifthly, inspect the installation. Sixthly, maintain the equipment. Seventhly, follow local codes.